Hi all, this is my kitchen LED inverter, tridonic. Let's see what the problem with it if I can fix it. This is the input, 220 volt, output 350 volt DC with a limit current of 350 milliampere. So let's take it apart. Okay, so basically this is the circuit, not very sophisticated. Let's go over the input. Going to capacitor, there is a coil, several more capacitors, and this is some kind of protection against spikes. Again, more capacitors, and then on the other side we have a few more components. So we can see the input going from these 2 points. By the way, this is a fuse. This is a PCB fuse, which means instead of putting expensive fuses, by the width of the PCB trace, this is the current that limit a high current. Let's take a look. I'm using it on short and we will see if it is going anywhere. So this one is okay and this one is disconnected. It's going to the input of the fuse here. It's like a triangle, you can see here below the red mark. And from here to here it is disconnected. So next thing to check is, of course, the diode bridge. Here it is. This is a rectifier, 4 diodes in one package. So let's see what we have here. Input no short, output no short. Aha, we have short between one input and one output. This is not okay, but I can't know if this is the diode itself or maybe this is in the PCB something that is causing this short. I really don't know, but anyway it's not okay. So even if I fix the fuse, it will blow again because this short. So let's remove this guy out with an iron. How to do it? I have a solder remover. Of course there is a polarity, so you need to pay attention how to take it out and how to bring it back. 2 inputs are the phase and the output, you have a minus and a plus, so just need to make sure that I don't flip it, that's all. And even if this guy is in a short, can something else cause the short? Wow. Okay. Let's see outside if it is shorted or the circuit is shorted. No short on the circuit. Yes. So this rectifier is no longer working. So I need to replace it and then we'll be able to check. Hope that no other thing cause this rectifier to blow up. I can do a fast check on the MOSFET here, which is not shorted, and what you can do else is check that your capacitors are not shorted. If one of the capacitors is short, so probably you have a problem. By the way, what? Do you see this capacitor here? This is first time I see it in my life. The two contacts, you can see that they are short on the PCB, which means this capacitor is not in use at all. They put it for what? First time I can see it. Look for yourself. You have two contacts that are shorted on the PCB. So this capacitor is shorted on the PCB, which means it's not in use. And also the other side capacitor is not in use. It's killing me. Yeah. Two capacitors shorted on the PCB, and by the way, this trace is not connected anywhere, so I have to find this company understand. Maybe it is a spare part for other part that can break down, but very funny things. Tridonics, I like to get comment on this. Okay, of course there is a chip here. Which I don't know what it is, but it doesn't look that it is shorted. Probably this is the current limit device. And other than this, that's all. So we have one fuse, one rectifier, two shorted capacitors that will remain short. Replace all these things and see what happens. Okay, I found another power supply. So I will take the part from here and move it to the other side to here. It looks to me okay. So let's remove it. If I can remove it, need some tools to take it up from the PCB. Yeah. Now we'll put this guy here. Good. Nice. Let's check that the short is not here anymore. We had short from here to here. Solved. So now I need to fix this tiny fuse. Now I don't exactly know how to do it, but what I do is just put a tiny wire from here to here that will act like a fuse. Now I'm not going to calculate anything. The reason is that I have the same fuse on the other side, so even if I connect here with a higher fuse, this one will blow up if something is wrong. So I guess I will do something and then hopefully it will be okay. Okay, for doing this I am just taking regular wire, removing its isolation, and then I have many tiny wires that I can use. So I will take maybe a few of them, something like this, maybe a little more, I'm not sure, but again I have the fuse on the other side, so it will be okay. Now what I'm going to do is put a little solder and solder it. Again, this is not very accurate about the current size because I can calculate, but I'm not going to do it. And what I will do, I will put it from this part here, if I manage to do it, to this part here. Yeah, something like this. Yeah, not very accurate, but I guess better than nothing. Now of course I need to check that I have continuous, which I did not have from this side to this side. Now it's okay. This side is also okay. So just need to close it and hope it will not blow again. Okay, so let's close this guy. This is probably something to prevent overheating, and this should go like this, I guess. Yeah, something like this, and this should be going like this. And since I don't want it to explode on my face, I will also put this guy back. Primary. This is the other side, like this. Yeah. Now we need to see if this is exploding again, but I have few, so let's do the test. So I have connected everything, hope nothing will explode. I have a power that I can immediately stop here. You can see it, I have a switch. Let's see if we have a voltage. Is this connected? 156 volts. So probably this is okay, because it's a current limit and it's apply voltage against the current, and this have a very high impedance, so it's not like a LED. So I guess if I connect it now, everything will be okay. We'll test it and see. Okay, now is the real test. Let's power it on and see if it's not exploding. And this is working. I don't like to do this fix and disclaimer, this is dangerous. This is a switching power supply. Don't do it at home if you're not familiar with all the safety. Thank you and bye.